For more videos like this for Compark 211, you can check out Sarai Studies. Link is in the description box below. We're given a truth table and we're told to draw the circuit. Now in this lesson, we're dealing with just three things: truth table, circuit, and formula. No matter what you're doing, no matter where you're going from truth table to circuit or the other way around, you need a formula. So we first have to find the formula from this truth table, and there are three ways to do it. I did a video on it, but because I see less ones and zeros, I'm going to do the method that takes the least amount of work for when I have less ones, and that's going to be expressing my formula as a sum of products. That's just a fancy way of saying find all the cases for when f is true, and f is true when it's 1. So we can write our formula as the first case for when f is true, that is when a is false, b is false, and c is true. So we can write a is false, we write as not a, or the opposite of a, so a prime or a bar, and b is false, so not b, and c is true, so we just write c. Now we don't like words and formulas, so we recall that we can represent and with multiplication. So we could replace that with the multiplication sign, which we don't even need because we know with multiplication we can just write it as such. So this is one case for when the output is true. Another case when it's true is right over here. So we can say this is one case where it's true, or, so remember we represent or with addition, where a is false, so we have not a, and b has to be true, so just b, and c has to be true, so just c. And again, we can represent and with multiplication, so I can replace these ands, and again, we can just write it as a prime times b times c, and that's another case. The output is true here as well, where a is true, b is false, and c is true. So a is true, and b is false, and c is true. Again, and can be multiplication, so we could just write this as a times b prime times c. And that's it. This is our formula. We expressed it as a sum of products because it's literally the sum of products of things being multiplied together, because it was faster. If we use product of sums, which is literally you switching the letters, it's the opposite. So we would find the opposite of f, so f prime, where all of the cases would be when the output is false. We would have had to write more cases and do more work, and then we would have to invert. So that's more work than we needed to do. This is just as good. Now we have the formula, and we can go from formula to circuit. So to keep things clean, I always like to find out how many inputs I have. So I have A, B, and C, disregarding any operators. In other words, from an algebra perspective, just look at how many variables you have. You just have A, B, and C. So I'm going to do A, B, and C, and I'm going to do a line for each of them. And then I'm going to draw a little dot, and then I'm going to extend the line, but I'm going to add a NOT gate. So this is going to represent A prime, because I'm taking the opposite of A. So I'll do that for the rest of them as well. So this represents B prime, and this line will represent C prime. So then I focus one by one, so I'll do this one first. Notice that these inputs are being multiplied together, so I need an AND gate. The first thing that's going to go inside the AND gate is A prime. So I go to the A prime line, I'm just going to do a dot and then drag it down in here. The second thing is B prime. I'm going to go to the B prime line, I'm going to do a little dot and drag it down into the gate. The last thing is C, so I'm going to take C right over here and drag that down into the gate. So the output of this gate is going to be A prime, B prime, C. Now let's leave it like that for now and move on to the second one. Again, this is all being multiplied together, so we need an AND gate. I see A prime, so I'm going to grab A prime, bring it all the way down into the gate. I see B, so I'm going to grab B and bring it all the way down. I see C, so I'm going to grab C and bring it all the way down. So that's this gate, and it's going to have an output. Let's move on to this one. Again, these things are being multiplied together. They're all going to go inside an AND gate. I see an A, so I'm going to go to the A line, do a little dot, and drop it all the way down to the gate. I see B prime, so I'm going to go to where B prime is, do a little dot, drop it all the way down. And finally, I see C, so I'm going to go where C is, do a little dot, drop it all the way down. So this is this gate, and it's going to have an output. Now, where are all of these outputs going? Well, the output of this gate and the output of this gate and the output of this gate are being added together. When you're adding something together, that's an OR. So we need an OR gate. An AND gate is a straight line. With an OR gate, it's a little curve, and then you do another one like that. So all of these outputs are going to be added together with this OR gate. So the output's going to go here, this output's going to go here, this output's going to go there, and the whole output is your formula. It's literally this entire thing. So this whole thing, the output of this OR gate is F. And so hopefully now you understand that the circuit, the formula, the truth table are all the same thing. It's just different ways of representing logic. This formula represents this circuit, and so does this truth table represent this circuit. And maybe it even makes more sense to you now. The reason we want to do truth tables, because if we have a circuit, we know that its output is represented by this formula, and let's say we want to know all of the possible outputs of the circuit depending on what A and B and C are, then we can do a truth table depending on what A and B and C are, we can get all of the possible outputs. So it's it's a nice way to see everything that might happen depending on what you have for A, B, and C. And so they're all connected. I'll see you in the next video.